Okay, here we are in part 2 of this experiment. The dot is almost stationary. The movement is very small, maybe 15 millimeters either side of that black line. Okay, I'm going down the other end now, where you'll see 2 piles of bricks and the pendulum in the centre. So this is seems to be a very balanced situation. I'm going back down there and I'll actually remove one side of the bricks. This time I'll remove the right hand side pile. Walking down 8.5 metres away. Right, about to remove the right hand side pile. Starting now. Going back the other end to the laser dot. As expected, the swing has gone wild. Okay, now what I'll come back at the 7 o'clock mark. That's our 15-minute benchmark that we seem to be establishing, just to see how quickly it settles. See you in 15 minutes. Okay, here we are at the 7-minute mark, 7 o'clock mark. Now swing hasn't appeared to be slowing down. In fact, it seems to be accelerating to the left. Very similar to the other part 1 where I had the bricks removed on the left-hand side. And we're going off scale a little bit. And that rapid acceleration back to the centre is just keeps going. This thing does not settle with one pack of bricks. Okay, I'll go down the other end and remove the other stack of bricks and just leave the pendulum. Here we go. 7 o'clock. 1 minute past or something. Walking down the other end, trying not to walk in front of the laser. Trying not to create wind drafts. Okay. Moving the bricks now. Alright, just editing, and I just realised that I didn't capture the other pile of bricks on the left hand side being moved. The camera died, but basically this is the gap that it ended up with. And equidistant by the looks of things. Going back to the other end. Maybe my imagination, but it does appear to be slowing down already. Not reaching that black line. It'll now centre itself somewhere between that black line and the edge of the ruler. I'll come back in 15 minutes from now. See you in 15 minutes. So here we are at 15 minutes from our last, and to me it's almost stopped. So I think what we can say is, although it doesn't quite stop oscillating, the oscillations are certainly smaller in amplitude and in frequency without the bricks. The same appears to be when the bricks are balanced either side, 2 rows of bricks either side, appears to be the same condition. However, when 1 row of bricks is removed, the amplitude of the swing and the period of the swing increases. And to me, it looks like with 1 row of bricks, it is being amplified somehow. I can't explain this yet. There's more experiments, more data. Now this is, must remember, this is just some very preliminary tests to work out the reaction of a mass of bricks against the pendulum stationary, and this is nothing like where Cavendish, we haven't even approached Cavendish's experiment yet. So, alright, look, enough rambling, we haven't got enough data. I think at this stage we'll go to, stay tuned for part 3. Back again, a little bit of extra data for us. It's now 7:30, and what I've noticed is this thing's slowly creeping to the right. So the swing period seems to be roughly the same amplitude, but it's creeping further to the right, which will, I've had to move the camera because it's actually, it's hitting the wall on the other. I'd need a huge room to actually measure this, but this thing's actually sweeping on a very slow arc around to the right. So it wants to settle somewhere. Again, this is probably a very good example of this node bias that I experienced throughout this pendulum, where you just sit a pendulum, unless it's got a laser mounted in it, you never notice it, but the bob actually creeps around, and we've gone off screen, it's hitting things. So anyway, a bit more data for you. Maybe that could help with someone. Thanks for watching.